Yeah.
Hi. Oh, okay. Got it. Hello, my name is Gayoung. Currently staying in Seattle, United States. Right now it's 5 a.m. So sorry that I didn't join the morning session. I bet it's amazing. I am a PhD student at the University of Washington. I'm working on my dissertation about technological change and human behavior change around 40,000 years ago. So it's quite old, hoping that I can finish anytime soon. But during my PhD, I've been following the principles of open science and conducting my research based on and writing paper based on that without even noticing it. Just thanks to my advisor, I thought that's how all other people do it. So I want to share about my personal journey with you to introduce some of the benefits of open science, open analysis, and how I do it. So I'm not talking about I'm not talking about any like fancy principles or any like background ideas behind this. I just simply want to show my personal journey that how I converted to use R and Git from Excel to Google Sheet to R. And I also want to show my just example project that how I start my analysis for normal array. And I also want to share some resource, some courses for learning R. Okay. Then why do we use Excel for analysis? Obviously, everybody use it. It has been used for a long time, everywhere, anywhere in your work or school. So it's really familiar to use and pretty easy and pretty straightforward to figure it out how to use, how to put data, how to do analysis. Compared to this R, which is pretty much super hard for me. There definitely have some learning curves. And I had no like engineering or coding background before I get into this program, my PhD. So it definitely hard. And I didn't learn from very beginning. Like once I get into my program, everybody expect me to already know how to use it. So I had like a little bit of rough road to learn R. But still, it has a lot of benefits. And I still believe that it is worth to learn how to use R. So because it makes much easier to replicate and reproduce your research and other people's analysis. So there's a little bit of like summary. By using R, it is easy to use, edit, expand your both data and analysis. My analysis will be super easy to be used by other researcher, and it's going to be super easy for other researcher can actually explore and check your research. They don't really need to use your research, but they can actually check. By doing that, providing the whole process, your analysis, you can actually make transparency of your studies, and people can see how you exclude some outliers and how you combine certain factors for the analysis. So it's just pretty handy. And I just want to show you some of my experience, some of my few papers of my master's back in Korea. I wrote it this like 10 years ago. Is super poor. I hope nobody understands Koreans in here. So yeah, this is my part of master's thesis. I use Excel for all analysis and create these little tables. But now I'm working on my doctoral dissertation, and I still need to use some of the raw data that I use for this research. But I lost all my Excel files, of course, by switching my laptop several times and moving to different country. And basically, I'm not very organized person. So I spent hours and hours to retype all the raw data from this paper to my new data set. But now I don't really need to worry about my future research, future data set, because my raw data is all secure and ready to use in my online repository. So I hope you don't have the same experience that I have. Using R and understanding R gives me a great opportunities to explore some novel methods and data that other people provided. One part of my dissertation is understanding some relationship between climate change and technological transition. But unfortunately, we don't have really much information about this paleoclimate like 40,000 years ago in Korea. But then I found this research last summer that provides some simulation-based climate data for my target period. And they kindly shared their data set and code that I can use at the very bottom of their research. So whenever you want to check other people's research, you just scroll down all the way down of their paper, then you can see some supplementary materials, and then sometimes, hopefully most of the time, people share their data and code. And they provide R scripts for their data set I can easily adopt to my work, my research. They also provide some scripts of different coding language like Python right there. But I found that archaeologists often use R for their research, so it's really handy for me to learn R. So using their data, I could create these cool figures that show some temperature difference between each archaeological sites in Korea. And I can also make some plots that show some temperature patterns through time. You can see that there's a little peak around 30,000 years ago, which is handy for me to build my arguments. And I could also combine some other factors with this temperature change with like appearance of new hunting tool called standpoint in Korea. In addition to the data, the simulation data, I also found this research. I was looking for how to connect the technological change to population change, like demographic patterns. And this method called summed probability distribution using SPD of radiocarbon dates. I think by now, like all archaeologists in here maybe notice this method, SPD. This generates some simulation or and statistical assumption about population pattern. Again, I checked their supplementary materials to see whether they share their codes, and then I can apply. And they did it. Again, at the end of the paper, they shared this supplementary materials. And they, not just for code, they also provide some whole explanations as a whole package. So I was able to use their methods super easily, but the design of the plots that they created are not super colorful or fancy enough for my standards. So I searched for another studies that use the similar SPD method, but then create much better, like much colorful plot that I like. And they also share the R code. So this specific research is not really targeted or my same research period. They're working on some Holocene period. Mine is Paleolithic, Pleistocene period. So the research itself is not related to mine, but the code for creating code is really handy for me. So this is my final result, final plots combined with two different research, one from the method from one paper, some code for a plot for from the other research. I focus 40 to 30,000 years ago, and you can see the peak again. So then I can make some arguments related to the technological change in human population change. So now whenever I hear about some novel approach or new fancy methods, I don't at least need to worry about how I use that method for my research, because a lot of people share their R codes, and I can just like study their codes and just adapt to my data set. Another benefits of using R is really easy to manage data. We can manage large data set using R. You don't need to scroll all the way down you normally do for Excel. And it's easy to manipulate data if we need it, but always secure the raw data. That's pretty important. And it's super easy to automate your analysis and super faster. So I want to show you another of my tragic example here. Yep. So I submitted one paper with the plot that I just showed you, and I got super long comments from my reviewers, and this is just tip of the iceberg. And the comments of this just simply said, add new assemblages from stone tool assemblages from newly discovered archaeological site in Korea, and then which means I need to manually add data set, which is, yeah, I need to do that anyway. But then I need to do all the analysis and then recreate all the analysis and all the plots, and then redo some part of my texts for the paper. But thanks to R, I still need to manually put the data. But for the analysis, creating plot part, I can just like run the code, and that's it. They generate new updated plots and updated text just by clicking enter. So that was pretty handy. And use R, you can load different types of data like text files, CVS file, HTML files, and other statistical program files. And again, I'm still using Excel and Google Sheet for my raw data. And there's a code that you can run those data too. And this is actual example of my scripts. As you can see, I use CVS, Excel, TPS, which is the little point, the XY coordinate data. And I also use a whole list of files as a data. So I can also wrote on my R, and I use a chunk of code as a data, which is RDS file. You can still open it too. Another benefits, if you use R, it is super easy and handy to organize your data and analysis. And there are many tools and packages that help you efficiently organize your work. So in my project folder, this is my actual project folder, you can see different files like data, figures, paper, and submissions and templates. So all my raw data goes to these data files, and all my figures goes to the figure files, and my scripts and text goes to paper files, and all other submission related files like cover letters, my rebuttal letters, that goes to submissions. And in case if I use this research for writing books, there's some all templates, it goes in the template files. So it's pretty handy. So whenever I need some raw data and figures, I know where they are. I need to worry about it. I don't need to worry about switching my whole computers and going to different country, because they're I know they're there. So yep, it's pretty cool. And if you use R, you can easily fix the errors and your mistakes. And you can see the little yellow triangular box next to these line numbers. There are kind of warning signs. They're not super fader signs, but still warning me that I'm not like super good, showing that I'm not super good a coder. They just, minor suggestion that you need to put some space in between code and parentheses and something like that. But if you have some like super fader errors that cannot make your plots, then they show what's the errors in here. Sometimes I don't even know what the meaning of this error message, but don't panic. You can copy this error message and just Google your message. Then just Google will, other people already had the similar experience. They will tell you what the issue are, and they just give you some suggestions too. Since I openly share everything with my future collaborator and other researchers, I also tend to put some notes with this in green color, like how I did this, or some messages like, oh, I excluded this site because of some outlier issue or something like that. So taking notes is really good, really easy. I think among all the benefits, this is the main reason why I still use R. I think R is enable me to do advanced data analysis and create this kind of super cool figures as a side project with my advisor and Ling, one of our presenter. I have this project that investigate how archaeologists use certain keywords throughout their throughout time and in their scientific research. So this method is called text mining methods that mostly used by some computer science people. So we don't really have any like background knowledge about this method whatsoever. But thanks to R and the code, and a lot of people share their code, so we could still explore how archaeologists have been like dealing with or discuss about these keywords, like important racial issues in their research. And then I could create some super cool plots like this. And maybe it's most important thing, R is free. Compared to Excel, like or other Microsoft suite, Excel is free and open for the public. Since I'm still in school, maybe money is not very important factor for me because my school pays for this kind of programs. But I know some of my friends, when they were about to graduate, they are super hurried to download all these programs before they leave the school. Yeah, these are pretty expensive for individual person or a small research institute. And these are the price range for SPSS, another statistical program. It's pretty expensive. And these are just another examples of the statistical analysis, the price range, like from a couple hundred to a couple thousand. And by using R, I can be involved in many different online communities. I'm part of R Ladies Seattle in Twitter. It's really cool. So you can also join a lot of different communities like today, like we have good community here. And whenever you have questions, again, go to R and then just type like R help and then copy all the errors and then your questions. And there's so many people, so many posts that you can get the information from. Or if you couldn't find any information, if you think you're the only one who had that error message, then just post on your community, then they will like happy to like answer your questions. And there's more collaboration, some opportunities too. And this one, another benefit, I kind of a little bit awkward to share this benefit with you. I don't want to kind of have some bad influence on you, but having R skill is bonus for your future careers, whether you want to stay in academia or industry. Still having R skill is kind of benefit and plus to broaden your having your better potential. I for myself actually has another job at this moment besides writing my dissertation to pay up my tuition and pay my living expense in Seattle. So I had a job in one of the tech company in Seattle as a data analysis. You know, like with archaeology PhD, soon to be PhD kind of status, it's really hard to get a job in tech industry. But since I have an R skill, I could get a job. So I don't want you to go to the industry, but still, it's good to know that we have an option just because we are having these skills. In addition to R, I also use Git, a version control system, to track down my research process and work easily with my collaborators. This is my GitHub page, a hosting service for Git, and function as an online repository so that I can store like all my codes and my raw data. And you can see here, you can see when I made my last change for this particular project. Version control is the just practice of tracking and managing all the change to this software code, and help manage changes to, you know, like changes in your files. And good for collaborating because you can see that what my collaborator changed and when they did it, and you can see whether you like the changes or not. If not, you can ask people to like restore to that the finer changes that I like. Just go to there and not this one. I don't want to accept this one. So does my collaborator can do the same thing to me. Like, I don't really like this last change that you make. Let's go to the previous version. It's super easy to do it. And I think Google Sheet and Excel has a similar one called version history. This is my raw data. I have these archaeological sites, time range, and some typology, and I just marked. You can see this all history that I made, the change that I made, and the similar things on Excel in here. It's very similar to the Google Sheet. But version control has from Git has better kind of overview of your changes. I can make some summary of my changes in here so that it's much more easier for my collaborator to see my changes. And then if you click these individual items, then you can actually see the whole changes too. So you can like easy to go and check and accept the change or not accepting the change, something like that. So that was all that benefit that I feel it's a rare. And next one, I was wanting to show the whole process how I make the new project, how I start my analysis using R and Git, but I think we don't have much time for that. So I just want to briefly show. So before I start my actual coding or my script, I create some my online repository in GitHub, and using the GitHub page, you can create a new repository and hopefully pick a good repository name. My advisor always make fun of me that I have like worst possible repository name, but I believe in you. You'll make better one. So again, this is my example. And then you go to our studio, create some new project, create new project, go to here, and then I use version control using Git. So select version control, Git, and then copy and paste your repository page, website page. Then you can start creating this kind of script or your RMD file that you can put some text in it. And then after finish all my work and ready to submit, or after submit, you have like refined good result, good paper. Then I shared my paper, this OSF website, and then just simply connect my GitHub page so that people can follow, people can go to my GitHub page and check my research. And then this is some resource that you can learn are, I just briefly show all that resource that I gathered for you. This is online workshop. Then again, one of our presenter, Ling, and I are involved. University of Washington Anthropology Data Science Working Group we offer some free online workshops once or twice per quarter. We teach how to use R from scratch, and we also teach how to use Git and GitHub. And sometimes we deal with some fancy methods like how to use GIS methods, or even how to create some fancy like websites for you. And there's some like school based workshops in here. And this is one example, again, from my school. We have some workshops, but it's not for the public. It's for people who are still in school. So maybe if you're still in school, you can easily find some workshops opportunity from your school. And this is based school too, but it's online, like accessible to everybody. So you can also check it out. And some university actually offer extra normal course for archaeologists or other social science. The curriculum must be not like super fancy or super hard that only computer science people interested in, but still like solid enough or good enough for social science, excuse me. And again, this is my advisors, and he offers some basic R and coding skill course for archaeologists. And actually, I talked to him like the other day and talk about our workshops. So he offers you to check his website, and you can actually see all the lectures. You may need to request some access, but he will answer shortly, and then like let you watch all these lectures that he did this year. Yep. So you can also check it out. If you want, I can post these links on our Slack channels. This is another example by my advisors. And there's an online course that you can find for free, like from Udemy and Coursera. They are all free. And these are some coding exclusive like website. They're not free, but this is super good. Like you can learn from like very beginning, like one by one, like step by step. But again, this is not free. But maybe if you are instructor or professor, or if you have like your own advisor or professor, they sometimes have some coupon for that students to use like a couple of quarters. I actually use this one like 3 quarters for free through my advisor's code. So you can check it out too. And there's still a lot of lectures are available online. So you can also check it out. These are all free thing. And there's always YouTube. YouTube videos, there's so many, and teaching R. And I have paid membership. Everything is like advertisement free, so I use it all the time. And yeah, that's it. That's all I prepared, and I just suggest small steps for you. Just think about how to make your analysis transparent, open, and clear, and think about how to make your analysis reusable, replicable, and reproducible. And just simply start learning R and get involved in this open science community. Just stick with us. And that's it. Thank you so much.